Okay, this is a lesson covering or reviewing how to add and subtract fractions. You see that we have to have fractions that have a common denominator. We need, and I'd like you to write this down, please, we need to find an LCD, a lowest common denominator. And those are the capital letters that we will use to stand for that lowest common denominator. And this only applies for addition and subtraction. You do not need a lowest common denominator to be able to multiply or divide fractions. That's what separates yesterday's lesson on multiplying, dividing from today's lesson, adding and subtracting. The approach will look a lot different. You have to know what to do when. Denominators can only be changed by multiplying the overall fraction by 1. That means that if you're going to change a denominator, you have to multiply the top and bottom of the fraction by the same expression. So if we multiply top and bottom by 5, we're really multiplying by 5 divided by 5, which is equivalent to 1. That's what step 2 really means. You're making each of these fractions into higher terms. You're used to doing that back from elementary school with fractions and arithmetic. You changed 3 over 4 into 6 over 8 back in elementary school by multiplying the top and bottom by 2. So we're employing the same technique here, only with algebraic fractions. So the directions in exercise 1 say, combine each of the following fractions by first finding a common denominator. So we need to identify a lowest common denominator. Express your answers in simplest form, which generally means you leave your denominators factored. So you see if you can actually cancel anything out in the end. And that will reduce it and make it in simplest form. So the first thing we notice with A, B, and C are they're all adds. We're adding fractions. We need an LCD. So on the side of our paper, we're going to write, we need an LCD for letter A, and that LCD is going to be equal to the lowest number that both 4 and 6 go into. That's like finding the least common multiple of 4 and 6. So if you count by 4s, you go 4, 8, 12, 16. If you count by 6s, you go 6, 12, 18. It's the lowest multiple they have in common, which would be a 12. So both 4 and 6 go into 12. If you pick 24, 24 is a number they both will go into, but it isn't the lowest number they both will go into. If you pick 24, you're not doing anything incorrect. That just means you're probably going to have to reduce in the end. You're making your numbers bigger than they have to be. They already both have an x in common. So they already have what they need. So our LCD is 12x. So we're going to bring that down in one big fraction bar. That's the next step. Get your LCD and carry it down in one big fraction bar. We're adding 2 fractions. We're making it into 1 fraction. And here's the step where you really need to watch. It's not hard. You just need to watch. You have to compare, and watch my pen, what you have, in this case we have a 4x in the denominator, to what you need to have, a 12x. So we're missing a factor of 3. So that means we're going to take the first fraction and we're going to multiply its top and bottom by 3. Now 3 divided by 3 is equivalent to 1. So in multiplying its top and bottom by 3, we're not changing its value. We're just changing the way it looks. We're making it into higher terms. So I call that a front multiplication. Because on top, we're going to hug that binomial with parentheses, the 2x minus 5 with parentheses, and that's going to remind us to distribute. When we distribute a monomial to a binomial, we usually put the monomial out front. So on top, we're going to get a 3 times 2x is 6x, and 3 times negative 5 is a negative 15. And that would be divided by 3 times 4x, which is 12x, which is what we already have. So we got the denominator the way we want it to look. We got a 12x for our first denominator. Now bring down your connector sign. You're adding that expression to the next expression. Now again, in this step, you compare what you have, a 6x, to what you need, which is a 12x. So here we're missing a factor of 2. So we'd have to front multiply the second fraction by 2. Its numerator and denominator. Both its numerator and denominator. And in doing so, I'm going to put that times sign there. I'm going to squeeze in a 2, and I'm going to remember to hug the binomial in back of the top 2 with parentheses. And on bottom, we're going to multiply the 2 by the 6x, and that's going to give us the 12x down there. So both the numerators and denominators are going to change, and the denominators are both going to change into a 12x, which is what we need. So we distribute the 2 inside the parentheses. We multiply it in, we get 8x plus 4. So the next step would be to combine like terms. Now, try to string your steps together with equal signs and give yourself a lot of room to do it. I'm anticipating I'm going to need space for B, so I'm not going to put my answer over here. I'm going to try to make a road map and go down there. When I combine a 6x with a positive 8x, that makes a 14x. We're combining like terms now. We're done multiplying. And then a negative 15 and a positive 4. And watch out, when I circled the 6x, it sort of made the negative sign look like a plus. So negative 15 and a positive 4 make a negative 11. And that's all over 12x. And there's no way we can factor 14x minus 11. Pulling out a GCF, no way, it's not the difference of squares, to be able to reduce this. So that would be your final answer.
12x.
Thank you, Jeff. It should be a 12x. I admitted that. Okay? Okay, now I'm going to sort of section off letter A from letter B and go to letter B. Letter B, we look at the fact that we're adding fractions. We're going to need a lowest common denominator. So on your paper, I want you to first step write down what the LCD is. All right, between the 5 and the 10, what's the lowest number that they both go into? A 10. And this time they don't both have an x. If one has an x and the other one doesn't have it, they are both going to need it. So they both need an x. One of them has it, the other doesn't. They're both to need it. So now we bring down a long fraction bar, and we put that LCD in its denominator. And now the next step is to compare what we have in our first denominator, 5x, to what we need, what my finger's tapping. We need a 10x. So we're missing a factor of 2. So we're going to multiply the first fraction. We're going to front multiply it, put that multiply sign in there, by 2 on the top, hug that binomial with parentheses, and a 2 on the bottom. On the bottom, 2 times 5x gives us what we need, our 10x. And on top, distributing the 2 inside, we get an 8x minus 2. Now the second denominator already has the 10, but it's missing an x. So we're going to have to front multiply. I'm going to anticipate multiplying the binomial by x by hugging it with parentheses. We're going to have to front multiply it by x on top and x in the denominator. I'll put my multiply sign in it. We're making each fraction into higher terms. So now distributing the x inside, x times x is x squared, so we bring down our addition sign. Don't forget your connector sign. Plus, x times x is x squared, plus x times 5 is 5x. And that will equal, again, my road map goes underneath because I'm going to need room for letter C. We combine like terms on top. There's only one x squared term. So there's nobody to combine that with. We just bring down the x squared. We can combine 8x together with a positive 5x. Notice that I'm considering the signs in front of each. 8 and 5 makes 13. So it's a positive 13x. And then we have a constant of negative 2. There's no other constants, not like anybody else. We just tack him on. And that's all over 10x. Now, in the end, you always have to think, can I reduce it? Can I factor that trinomial on top and get a 10x out of it as a factor? No, I don't think so. They don't all have an x. We can't take an x out. I don't think we're close. You always have to think, can I actually, factor anything in the end to be able to reduce? So it looks like we're done with that. Let's go to letter C. Letter C, we'll put the LCD for letter C up here. We look at the coefficients, 2 and 4. The lowest number they both go into is a 4. One of them has an x, the other has an x squared. And here's a hint. When you're trying to get the lowest common denominator, you choose the variable with the highest power. It's opposite. So what are we going to choose between x and x squared? X squared, yeah. So our LCD is going to be 4x squared. So we bring our fraction bar down. And then we can do a comparison. We compare what we have, 4x, what we need, 4x squared. So it looks like we're missing a factor of what? X. We've got the 4. We need another factor of x. So we're going to have to front multiply the top and bottom by x. So that makes on top 3 times x, no more binomial there to worry about. And on the bottom we get 4x squared, which was what we wanted. And try to get in the habit of bringing down your connector sign. Plus, now compare what you have to what you need in the second denominator. We're missing a factor of 2, and we already have 2 factors of x. So the second fraction is really easy. We just have to back multiply it. In this case, back multiply it because the top multiplication is an easy one to do. Back multiply it by 2 or 2. 1 times 2 is 2, and on the bottom we get what we want, 4x squared. And there's no way we can factor 3x plus 2 to get 4x squared as one of the factors of it, so we know we're done. You always, in the end, have to see if you can reduce it. Reducing means factoring out, then canceling out. Okay, so it says each of the combinations in exercise 1 should have been pretty easy because each denominator was monomial looking. If this is not the case, then it is wise to factor the denominators before trying to get a common denominator. I don't know how many kids I get when it comes time to a unit test. They'll take a problem like this one, and they'll use both of those as an LCD. They'll use both denominators as an LCD. And they forget, when they're binomial denominators, you have to factor them first to get factors. So y squared minus 9 factors into y plus 3 times y minus 3. So I would suggest that you lightly X out or cross out or put a line through y squared minus 9 because we're not going to use that now. Okay? And then because these are so close together, I like to put a squiggly line in between them so I don't get my denominators mixed up. Everybody okay with that? Okay. Now we got to factor the other denominator, 5y minus 15. So we can take out a GCF from that, a 5, and we're left with y minus 3. So now that we've factored the binomial denominators, in order to add the 2 fractions together, we need an LCD. So our LCD is going to be equal to, okay, let's look through the factors that each have. One of them has a 5, the other one doesn't have a 5. If one has it and the other doesn't, they are both going to need it. So we need a 5 in both. They both already have a y minus 3, that's good. So they already have that in common. We have to write that down. And then one of them has a y plus 3 as a factor. We can see it as a factor because it's hugged with parentheses. The other one doesn't. So we're going to need a factor of y plus 3. Let's subdivide our workspace here. Try to stay in that space. Okay, equals. Try to string your steps together with equal signs. So we make a long fraction bar because there's 3 factors now we have to for our LCD. We put 5 times the quantity y minus 3 times the quantity y plus 3. Just copy your LCD down as your new denominator. What did I forget to do that I told you should be doing for letter A? I forgot something. Who can pick that up? Who's sharp enough to pick that up? What up there did I forget to do? Excellent, Lisa. You cross out the 5y minus 15 because you've already factored it. If you don't do that, there's too much to look at, I think. So now you compare what you have to what you need. So we have a factor of 5 and a factor of y minus 3. What factor is missing? Y plus 3. Good. So we have to multiply the top and bottom by y plus 3. Now, the 4 is already up there. He's a monomial. So I'm going to back multiply the fraction by y plus 3, because I'm getting ready to distribute the 4 inside the parentheses. You can put the y plus 3 in front, but then you're going to have to do your arrows backwards. And we're multiplying the bottom by y plus 3. So we get 4 times y is 4y. 4 times positive 3 is positive 12. Bring down your plus. Now look at your second denominator. Compare what you have, 2 factors, to what you need, 3 factors. What factor is missing? A 5, yeah. So we have to multiply the top and bottom by 5, and because there's already a 5 up there, it really doesn't matter whether we front multiply it or back multiply it. So 5 times 5 is 25, all over 5 times y minus 3 times y plus 3. We have those 3 factors down there. So that equals what we get when we combine like terms. We're done multiplying now. We get 4y plus a positive 12 and a positive 25, make a positive 37, good. And that's all over. And I would leave my denominator in factored form. And I say that because if you look at the numerator, and it does factor, and one of the factors is either a 5 or a y plus 3 or a y minus 3, you'll be able to cancel and reduce it. But there's no way to factor 4y plus 37. There's no GCF, and it's not the difference of squares. Okay? Okay. Stop right there, please.